Hello everyone, welcome back to What's Inside. This is episode 8, where we're going to be going over the infrared receiver, the infrared remote. There's a lot to this one, it's pretty interesting as we're going wireless. So make sure you stick around for the analysis, and William will go over a quick overview right now.
So we have one of these classic remotes, which you might see at your TV. And so right here we have just your classic buttons, the necessary buttons to the remote. So we have the numbers on it, the volume buttons, and so each one has a sensor. When pressed, it designates a signal to this other component, and it's going to give a command. For example, if you click the volume up, it's going to obviously turn up the volume down, lower the volume, and we also have the on and off button, which sends the infrared signals through wireless communication.
If you're wondering what this other component that William mentioned is, it's an infrared receiver. It's pretty interesting, and we'll get more into later.
Yeah, so let's get into this invisible wireless magic. So have you ever wondered how your TV remote actually talks to the screen without the wires? It's all due to the infrared light, which is a type of light that humans cannot see, but your electronics can detect. And this communication is essentially a silent handshake between remote controls and devices, making wireless control simple, cheap, and reliable. And today we're going to break down how this receiver module and the remote work together and how you can use them in your projects.
Yep, so how does infrared communication actually work? So first, there's the signal encoding, which remote converts button presses into infrared pulses. Then there's the infrared transmission, where infrared code sends coded pulses as light flashes. And then there's a signal decoding, where Arduino reads the code to know which button was pressed. Think of it kind of like Morse code, but with flashes of invisible light.
And so as you can see right here, this is the remote control, and it looks like a mini TV remote. And what it has a LED in the front that emits the pulses, and it uses a battery power to send the signals. So right now we don't have a battery, but if you imagine if you press one of these buttons, there's going to be a light or color from this LED. And then we have the IR receiver module, and it has 3 pins, the VCC, ground, and the out. It has built-in photodiode and decoder chip. And what it does is it receives these light pulses and it converts them into electrical signals.
Now, as for the internal working principles, pressing a button on the IR remote control turns the IR LED on and off as specific patterns, codes. And it uses modulated pulses, usually at 38 kilohertz, to avoid interference from sunlight or indoor lights. Each button corresponds to a unique code pattern. For the receiver module, it detects modulated IR signals via its photodiode. It filters ambient light to reduce the noise that is received, and then it outputs a digital signal representing the pulse pattern to Arduino. And William can tell you a little bit about the pins. They're actually, again, labeled right here. If you can see right there, William will tell you about it.
Yeah, so if we wanted to, how would we wire this receiver pins to the Arduino pins? So we have, as you can see here, the ground one, which is the G, and it's just the ground, which you can connect it to the Arduino ground pin. Then we have the V, which can connect to the 5 volts Arduino pin, and lastly the out pin, which can be connected to the digital pin 11 or any other interrupt pins. And make sure that this receiver faces the remote while you are testing this component.
And so, how do you use these in your projects? You can map hex code to a specific commands, such as turn LED on and off or move a robot around. You can also use switch cases to handle multiple buttons or build wireless control systems with easy to use remotes. And why does this modulation matter? the IR LED just stayed on while a button is pressed, the receiver couldn't tell a signal from ambient light noise. The modulation at 38 kHz means that the LED flashes rapidly on and off. The receiver looks specifically for this pattern, ignoring steady or random light.
And so moving on to the troubleshooting and the communication of this piece. So if there's no response from the receiver, the likely cause of this is that there has been a wrong wiring or the receiver was facing the wrong way. Strange or no codes printed was basically, it could be because the remote was too far or interface is present.
And yeah, there's a lot more that we can always cover about the IR, such as the specific components like the resistors inside, ICs inside, the actual inner workings of this, and the inner workings of the remote. But as always, it would take hours and hours before that we would finish talking about that. And if you have any questions, you can just email us. But yeah, for now, this is the IR remote and the IR receiver. Thank you for tuning in to this episode 8 of What's Inside, and I really hope you learned something. As always, make sure you stay curious because that's what's inside. Hopefully, I see you in the next episode.